Hi guys, I'm going to go ahead and record the notes for liquids and solids that we took in class today, just in case you need to see them again, or in case the PowerPoints don't want to download since we're having a little trouble on the computer. So, state of matter and the KMT liquids is a two-page notes on page 287. The top of it begins just like all three of these do. Main idea, the kinetic molecular theory of matter. Kinetic means motion. On the right-hand side in the box, the kinetic molecular theory of matter is based on the idea that particles of matter are always in motion. And for the draw and label, it is the same as we drew for the gases, or you can look in your book to see their diagram. Box 2, liquids. A form of matter that has definite volume and takes the shape of its container. Liquid particles are much closer than gas particles. They are more structured due to stronger attractive forces and can flow around one another. The attractive forces between liquid molecules are much stronger than the attractive forces between gas particles. Types of attractive forces acting on liquids are called intermolecular forces. It's all one word. There are three kinds, and then I'll give you a definition of each. The first is called the dipole force. The second is called the London diffusion force. London dispersion force. London spelled like the city, but named after a scientist. And the third is hydrogen bonding. So the definition for dipole is just where there are partial or weak positive and negative forces, so they attract each other. That would be like sodium chloride if it was dissolved, because the molecules would still be attracted to each other. The London dispersion force is the weakest. And it is simply due to the number of electrons in a molecule. The larger the number of electrons, the stronger the dispersion force is, but it's a weak force overall. And then hydrogen bonding is the strongest of these three, and it's due to hydrogen ions in a molecule attracting oxygen and nitrogen specifically, and those two molecules attracting hydrogen. Under fluidity, liquid particles slide past each other. A fluid is a substance that can flow and therefore takes the shape of its container, and liquids and gases are both fluids. Density. Liquids are hundreds of times denser than gases because they have a much closer arrangement than gas particles. Therefore, they are more dense. And density, remember, is equal to mass over volume. So they're in a smaller volume. It's more dense. Compressibility, liquid particles are already closely packed together, so liquids are only slightly compressible. Gases are very compressible. Diffusion, liquids also diffuse, but at a much slower rate than gases. Liquids move and diffuse through any other liquid that it can dissolve in. Remember food coloring dropped into water that people do in elementary school. The color will finally diffuse just because the molecules are bouncing back and forth. Surface tension, a force that pulls liquid particles together in order to decrease surface area to the least possible size. A single liquid drop will take on a spherical shape because that means it has the least amount of surface area. And the property of water that makes it do such things is hydrogen bonding. Page 2, capillary action, an attraction between the surface of a solid and the surface of a liquid. It pulls the liquid up against the pull of gravity. And this is what makes a meniscus in a cylinder. This is something they show you in lab, where the meniscus is sort of U-shaped because the water sticks to the sides of the cylinder. Vaporization, the process by which a liquid or solid changes to a gas. There are two kinds of vaporization. Evaporation, the process by which particles escape from the surface of a liquid and change to the gas phase. This occurs below the liquid's boiling point where there are no bubbles seen. That's what the parentheses is. For boiling, it's the change from a liquid to a gas within the liquid, so bubbles of vapor form throughout the liquid, like thinking about when a pot starts to boil in your kitchen. Evaporation, liquid particles at the surface have more kinetic energy than particles within the liquid. As the kinetic energy increases, the intermolecular forces are overcome and the liquid particles change to gas particles. Evaporation is a very important process in nature. Particles with the most energy escape first, leaving behind lower energy particles. Average kinetic energy decreases, and so the temperature decreases. This is evaporative cooling. This is like what happens when you sweat. As the water evaporates from your skin, it cools your body down. Evaporation in a closed system. Liquids in a closed container still evaporate. The vapor, which is the gas particles, build at the top of the container, like in a gasoline can where you can smell gasoline when you open the top. It's the vapor that comes out. Vapor pressure is the measure of the force exerted by a gas above a liquid. Once the number of particles condensing and the number of particles vaporizing are equal, the pressure remains constant, and that's equilibrium. Boiling, the temperature at which the vapor pressure of the liquid is equal to the external pressure on the liquid. When a liquid is heated, particles throughout the liquid will gain enough kinetic energy to vaporize. Bubbles of vapor will form and rise to the surface. Again, the boiling pot. The external pressure is equal to the atmospheric pressure. Atmospheric pressure is lower at higher altitudes. Boiling points are lower at high altitudes. If you live in the mountains, like in Denver, you have to adjust your cooking times because it takes longer. The food does not get as hot with a lower atmospheric pressure. The normal boiling point of a liquid at standard pressure is the last line there, and the standard pressure in parentheses 101.3 kPa, which stands for kilopascal, which is a measurement of gas pressure. And at the bottom, the model that demonstrates evaporation and boiling is found on slide 13 in your PowerPoint. Okay, that's all for the first PowerPoint. I will come back and talk to you about solids.